Convection, conduction, and radiation. Thermal energy moves in three different ways through conduction, convection, and radiation. Conduction, just all particles are moving. The greater the kinetic energy, the greater the temperature or energy. Energy is transferred from one particle moving at different speeds that bump into another particle. And this can take place in gases, liquids, and solids. The best conductors are, of course, solids. Some metals heat better than others, like silver and copper and aluminum are all great conductors of heat since the valence electrons are held so loosely. Wood, plastic, glass, and fiberglass are all poor conductors, and that's why we call them insulators. Convection is the transfer of energy by the bulk movement of matter. Recall that any material that flows is a fluid, so liquids and gases are both fluids. This is kind of a hard thing to wrap your head around because you don't think of a gas as a fluid, but it is because it can flow. The most important way thermal energy is transferred in fluids is by convection. So how is conduction and convection different? Well, in conduction, you just have energy moving. In convection, the bulk, the actual particles move. So if you watch a boiling pot of water, you'll see water moving from the bottom of the pot to the top. That's convection. Another way that you could see this is through air currents on the Earth's surface and also in oceans with the with currents in the ocean. Radiation is the transfer of energy in the form of waves. Energy that travels by radiation is often called radiant energy. This is how energy from the sun transfers to the Earth. Since there is little matter in space, convection and conduction do not take place. Different materials absorb radiant energy differently. Shiny materials reflect radiant energy while dull materials absorb it. Dark colored materials absorb energy more than lighter colored materials. That's why in the summer we like to wear lighter colors. And in the winter you can wear darker colors and be fine. You don't get overheated just because it's cooler out. This is also why the radiant barriers are normally a piece of mylar, which is just like a very shiny piece of material that's just able to reflect all the ultraviolet rays that penetrate your roof of your house. This is also why there's a big push to change the color of our shingles on our roof to a lighter color because it would reflect more. All matter that is warmer than 0 Kelvin emit radiation. So that's important. Anything that has any type of thermal energy at all will always emit radiation. So that's why our thermal imaging cameras work, because it detects the radiation being emitted. Insulators, well, we've already talked about insulators, is just a material that does not allow heat to move through it easily. Some materials such as wood, plastic, and glass we've already identified as poor conductors of heat, great insulators. However, gases such as air and argon are also excellent insulators when placed in the right situation. For instance, if we take and have a triple pane window, a lot of times the air inside the window is either just air or argon or nitrogen filling that void, because that doesn't allow conduction as well as if it was just a solid piece of glass. Insulation rating system. A rating system has been established in which material is given an R value. You might have heard people talk about that, like if you go to Lowe's or any other type of hardware store and you want to buy insulation, they're going to sell it by the R value. The R indicates resistance to heat flow, so that a higher R rating gives you a higher resistance to heat flow. An example, R40 is better than R20. Glass by itself has an R rating of 1. However, if the glass is double pane or even triple pane, then this increases considerably. You notice that at the school we have nice new windows. It used to not be that way. We used to only have single pane. Well, they were very, very energy inefficient. Now we've got double pane. It's not only noticeable in the electric bills of the school, but it's also noticeable in just how warm the room stays. Now, of course, you wouldn't know that because half the time our rooms are cold because we don't use the heater. Well, we don't use the heater on the weekends normally, or the air conditioner on the weekends. simply because we're trying to be energy efficient. And that they have a whole department that's just for energy efficiency. It's for Fort Worth ISD, which is kind of neat. There are two major types of heating systems. There's conventional heating systems, which include radiator systems, forced air systems, electrical systems. This is what we're most familiar with, but there's also solar heating systems that involve passive solar heating and active solar heating, and sometimes we have these and we don't even realize it. This can be as simple as where your windows are facing in your house. I was watching a show the other day where a lady she lives in Colorado. I probably said that wrong. I always say Colorado wrong. People are laughing right now. But anyway, she doesn't have a heater in her house. She has a small house with lots of windows and really, really great curtains that are able to act like insulators. So in the morning, she'll open up the windows on the east side, and in the evening, she closes those and she'll open them up on the west side. By doing this, she doesn't have any heater in her house. Now, she doesn't have a need for it. Now you're asking, well, what about the windows? Aren't they horrible at losing heat? Yeah, actually they are. Even if they're double or triple pane, they're not going to do as well as a wall. So that's why the curtains come in place. She has thermal curtains with multiple layers, so that way it kind of negates some of that heat loss. And it's a small room, so I think that probably helps out a little bit. Radiator system is just a device with a large surface area designed to heat the air near it by conduction. Convection currents then circulate the heat to all parts of the room. If you live in the north, a lot of the northern areas do have radiant heater systems. I know whenever I lived in Oklahoma, there was some in one of our houses that we lived in. Actually, the school has it. If you've been in the old part of the school, the main building, that still has radiant heaters. I don't believe they work, though. I'm not sure. They might. The newer parts don't. We use forced air in the system. So forced air systems, this is the one you're most familiar with. It's just a device that blows heated air from a furnace through a system of large pipes called ducts to openings called vents in each room. In the room, the warm air circulates by convection, cool air returns to the furnace through other vents and ducts to be reheated. So this is just your central heating air. Electrical heating systems. These are large heating coils located within floors or ceilings that are heated by electrical energy. Nearby air is heated by conduction, and people and materials in the room are also warmed by radiation. Such systems, called radiant electrical heating systems, provide even heat, however, are very expensive to operate. That's not the only type of electrical heating system, of course. There's also just the type that work in conjunction with a forced air system. If in Texas, we have a lot of these electrical heating systems that work with your forced air, your central heat and air. However, they're very expensive to operate. A lot of air conditioners are reversible. These are called heat pumps that are very, very efficient and comparatively to electrical heating systems and operate at a much lower rate. For instance, if we use the electrical backup, which have to operate at 32 degrees or lower, anytime it's freezing or lower, then your heat pumps will not work because it'll freeze the coils outside, because condensation of water will happen on the coil outside. Well, whenever these heating strips kick in, it costs a lot more. If we have a month that's completely below freezing, our electric bill will jump up by about $100 to $150 a month. So electrical heating systems are great for emergency situations or in conjunction with another type of heater. However, they do not work well by themselves. They're generally very, very expensive. Okay, solar heating, we've already touched on this. This is just energy from the sun. We get solar energy from the sun. Since it's free, it's very appealing as a heat source. Passive solar heating, just systems that use no fans or mechanical devices to transfer heat from one area to another. Some materials and systems absorb radiant energy during the day, convert it to thermal energy, and radiate the thermal energy after dark. Kind of touched on that earlier. This is a little bit different, though, in the fact that it actually radiates energy after dark. So that's kind of a neat thing. Active solar heating. This type of solar heating system, as you can guess, uses mechanical energy to help transfer heat from one area to another. A solar collector is often used for these applications. A solar collector is a device that absorbs radiant energy from the sun. They are generally mounted either on the roof or south side of the building. The radiant energy can be used to heat the house, water, or both. Whenever I was growing up, we had a shop because my dad was a sandblaster and painter, we had a shop in the back. And we had a shower in there for people to come in after they were done sandblasting or painting. They could go in there and shower in a little office area. We didn't have a water heater, but Dad would take, and he had just a black piece of PVC pipe he threw up on the roof of the shop that would heat the water. And he actually got, I mean, you could have a scalding hot shower in there. So, I think it held maybe 10 gallons of water inside that pipe. It was a very long pipe. So, this is a very effective form of heating water.